Let me make sure my microphone is on. Okay, perfect. Okay, so I'm going to go over 10.1 just because I know a lot of you have been out at various times this week. So I am going to go over the entire 10.1 lesson. This will be longer than it typically is just because this is a longer lesson. Kind of, I mean, it's like 9 pages, but there's a lot of graphs on it. So I am going to go ahead and go over this. Bear with me. I did, again, forget my key at school. So I had the key from Tarleton pulled up on my phone. So just bear with me for a minute. But so right here, we're really just going to fill out the information about this graph. And so what you would need to do, okay, is plug in this f of x equals 2 to the x power. That right there, you would need to plug into y equals to find what your table is, okay? Now, for time's sake, I'm going to go ahead and give you the values of the table, but just know the way that we found these values was by putting that equation into my y equals in my calculator and going to my table. All right, so 0.125, that's supposed to be decimal, 0.25, 0.51, 2, 4, and 8. Okay, so then I'm just going to go ahead and graph this. Okay. All right, so we have our graph here, okay? And so we are going to see what these answers are to the graph over here. So is it a one-to-one? Does it have, or what is the domain? What is the range? Asymptote, y-intercept, all that, okay? So as a reminder, the way that we see if it's a one-to-one is that we do a horizontal line test, okay? And of course, I'm doing multiple horizontal line tests here, but it does pass the horizontal line test. So is it one-to-one? Yes. And it's because it passes, I think I can move this. Nope, that's not what I wanted. Let me just move over here. Horizontal line test, okay? So that is how you know if it is one-to-one, is if it passes a horizontal line test, okay? Well, my domain here is not restricted. It is going to be all real numbers because it extends in both directions. You can also say that it is from negative infinity to positive infinity. That's the same way as saying all real numbers. Now, my range, it doesn't go below 0, okay? I tried to draw my graph as good as I could. Obviously, I'm not perfect, but it's going to get super, super close to 0, but it's never going to touch. So my range is going to be 0 to positive infinity, okay? Now, I do have an asymptote here, and it is right here at this line where y equals 0. So my asymptote would be yes. Now, what type of asymptote is that? Is that going to be a horizontal or is that going to be a vertical? Okay, that's a horizontal asymptote, and it's going to be at the line y equals 0. Okay. My y-intercept on this one is going to be 0, 1. Sorry, that's a bad parenthesis. And then this is an increasing interval. And it is increasing because when I go from left to right, it goes up in an upwards direction. So that's increasing, and it is on the interval negative infinity to positive infinity. Okay. All right. So now to number 2, we're going to do the same thing. Again, I'm not going to wait on you to type it in. Just go ahead and pause the video. But this is the equation you would put into your y equals. And so the values that you would get are these here. Okay. And so the same thing that we just did on the last one, we're going to go ahead and graph it. And you get something along, whoa. Obviously that is not perfect, but something along that line, okay? Now, the same way we did the first one we just did, just see if it's one-to-one. We're going to see if it passes the horizontal line test, and it does. So yes, it's one-to-one. And just because it's your notes, I'm just going to make this reminder. You're not going to have to answer. Well, you might have to answer this on the homework or the test. I wouldn't think so, but maybe. The reason it's 1-to-1 is because it passes. Oh, come on. There we go. Okay, it passes the horizontal line test. Okay. On this one, the same thing. The domain would be all real numbers or negative infinity to positive infinity. And the range on this one would be 0 to infinity. Okay. Same way, this one does have a horizontal asymptote at the line y equals 0. So yes, as an asymptote, it's going to be a horizontal asymptote at y equals 0. Okay. And so this y-intercept is also 0, comma 1. But the difference in this one is as you look at this from left to right, this is actually decreasing, and it's decreasing on the interval negative infinity to positive infinity. Okay? All right, moving right along. I'll be honest, these next two are a lot the same as the last one. You're just going to plug in the equation into your y equals and then find the table graph and then see what characteristics you notice about the graph. All right, so 15.625, 6.25. Okay, and then graph it. That's gonna be way up there. So this graph would be something like this. Okay, and again, it's still 1-to-1. The domain would be the same, negative infinity to positive. The range is 0 to positive infinity. It's got a horizontal asymptote at y equals 0. Y-intercept here is 0, 1. This one is decreasing, and it is decreasing on the interval negative infinity to positive. Okay. All right. So we put in the 10 to the x power into our y equals, and we get this table of values. Oh, whoops. I left off zeros. Okay. And this one obviously is going to be really hard to graph because it's a very small fraction, or decimal, excuse me. Okay, and same questions. Okay, 1-to-1, yes. Domain, negative infinity to positive. Range is 0 to positive infinity. There is a horizontal asymptote at y equals 0. Y-intercept is 0, 1. It is increasing from negative infinity to positive. Okay. Sorry if that was super fast. Sorry, it's the second time I've taught this. So what are some similarities in the first four graphs that we just did? Do their points follow a specific pattern? What commonalities do those characteristics share, and what difference are about the graph? So one thing that is the same is that they have this same domain, range, y-intercept, and horizontal asymptote. Okay, they also know x-intercepts. Also, I don't know if you noticed this, but if you looked at the equation, when the a value, which is the number that was raised to the power, okay, when it was less than 1, the function was decreasing. Okay, if a was greater than 1, it was increasing. So I'm just going to put vice versa here. Okay. All right, so some different characteristics of exponential functions. They are either always increasing or decreasing. sorry, I was decreasing. Sorry. Again, as I said, increasing on the one question above. So increasing whenever a is greater than 1. That's a terrible greater than symbol. All right, and it's going to be decreasing if a is between 0 and 1. Okay, so it's not ever going to be a negative number. It's going to be the between 0 and 1. And then also, the exponential functions have a horizontal asymptote, but no vertical asymptote. Okay? All right, so then moving along, and again, if you need to pause it, go ahead. I'm just going to keep trucking through it. So we have the number e, okay? It's actually like a symbol, I guess you could say, like pi, okay? It just means the natural base. And so, yes, there's a mysterious origin. It's irrational, it's going to keep on going on forever. And so it kind of gives you a way, that you can define it, all right? Now, using this formula, okay, we can discover that when n is 1, our y value is going to give us a 2. If we plug in a 10 for n, we would get, and it's a very long decimal, 2.59, 374, 24601. Okay? If we plugged in 100 for n, we would get 2.70, 481, 382, 942. 1,000, we would get 2.71, 692, 393, 224. And I'm just going to keep writing these, okay? If I was to plug in the n value, or the x value, if you will, if I was to plug that in for n, what would I get? Okay, 2682. And then we would get 2.718. 268, 23719. Okay, so we can approximate, because E is approximately 2.718, 281, 828, 459, 045. Okay, so we're going to approximate E to be this value right here. Okay, 2.718. Okay. And so we have, and when you're on your calculator, and if you're in class and you have the calculators there in class, E is, I believe it's right by the 4. It's in blue. Okay, so you'll have to hit second, and you have to hit the natural log button, which is the LN button, and you'll see it right above it in blue. But that's how you get the E. Okay, so in order to find this graph, we need to plug this table in, or this equation in for, into our y equals, And so then we would just fill out our table. So we'd get approximately 0.135, 0.3681, 2.718, and 7.389. Okay, that's what we would get as the parent function there of e to the x power. So then I'm going to go ahead and grab it. Okay, and just like we did on the first one, is it 1-to-1? Yes, again, because it passes the horizontal line test. The domain is still negative infinity to positive infinity, or you could just say all real numbers. The range on this one would be 0 to infinity. It does have a vertical asymptote at y equals 0. There is not an x-intercept, but there is a y-intercept at 0, 1. This one's increasing, and it's increasing from negative infinity to positive infinity, okay? Sorry, I don't know what that just did. Okay. So this is just some graphs and then the characteristics that we're seeing. You are going to need to know, like, the E, being the natural base, and we will eventually go into logs. And so that's the reason for bringing this up, okay? It's exponential and log functions. And so, yes, this is something that you will definitely see, especially if you're going to go into deeper math. You will definitely see this, okay? So make sure you're paying attention to this, okay? Now, I was telling the students today, because we started covering this part today. This next part that we're about to do, writing the equations, this is actually my favorite part of the notes. I get kind of bored with graphs, if I'm being honest with you, but this one was more, that's kind of my favorite part. So when we have this exponential function here, a times b to the x power. A is going to represent the initial value. So I want you to think of like y-intercept. Okay? And then b is going to represent the common ratio. And I'll explain in a second what that means. But just know for right now, our common ratio, that is where we would plug it in for b. All right, so I'm going to kind of slide in here. So I noticed that from 0 to 1, we added 1 there. Okay, we're adding 1. But over here on the right side, if I go from 3 to 6, well, I could add 3, but we need it to be a common ratio. But if I go from 6 to 12, I can't add 3. But I do know, if I take 3 and multiply it by 2, I get 6. 6 multiplied 2 gives me 12. Okay, and so that's one way that you can find your common ratio. You can also do it by saying, okay, my 12, my y value, divided by the previous y value is 6. And when I divide that, I get 2. And then same thing when I do 6 divided by 3, I get 2. Okay, so my common ratio is going to be 2. Okay, and then my initial is the y value at the y-intercept. Okay, so the initial would be 3. Okay, so when I come over here to this part, my initial is 3, my common is 2. So to write the exponential function, my initial value goes first, and then I go in parentheses 2, and it's to the x power. Now, I told them in class today, too, just to make sure y'all don't, make this mistake. You cannot do 3 times 2 gives you 6. And that be 6 to the x power. That is not it, okay? So do not think that I can distribute that, because that's not going to work. Because the 2 is what is to the x power, not the 3 times 2, okay? So whenever I need to find the f of 16, all they did is they plugged in a 16 for x. So I would say, well, 3 times 2 to the 16th power. And you are going to get a big number. But when you plug this into the calculator, you get 196,608. Okay? So again, as a reminder, what we just went over, the initial value, which is your the y value of your y-intercept, it goes first. And then the common ratio, which is whenever we just found the difference here, the common ratio between your y values, that's what goes second, and that is what is raised to the x power. Okay? Okay. So on this one, we don't have an initial value. It doesn't give it to us. But I know right now, 2 to 3, that's adding 1. 2 to 4. Or excuse me, 3 to 4. 4 to 5. It's all adding 1. So I'm going to go backwards to get to my y value. So if I go 2 minus 1, I can get a positive 1. And then if I go positive 1 minus 1, I get a 0. Okay? Well, now I need to see, what's going on over here on my y values? So from 45 to 135, I'm going to multiply by 3. And let's say you had no idea what number to multiply by. Remember, you can do 135 divided by 45, and you get 3. Okay? So that's how I know I need to multiply by 3. Okay, same thing if I did 405 divided by 135. I get 3. Okay, so again, I need to find my initial. So instead of multiplying by 3, I'm going to go backwards. And I'm going to say, okay, what's 45 divided by 3? So 45 divided by 3 is 15. And then to get to my initial, I'm going to do the same thing where I divide by 3. 15 divided by 3 gives me 5. Okay, so my initial value is a 5. And my common ratio is this right here, this 3. Okay, Now, one thing I actually forgot to write on the last one that I need to talk about. If your common ratio is greater than 1, it's going to be a growth. So let's go ahead and write that on this one before I forget. And let's also go and write it on the one before, okay, since I forgot to write that. Okay. All right, so I know my initial value is 5. I know my common ratio is 3. So my equation is going to be 5 times 3 to the x power. Okay. So when it's asking what f of 14 is, we're going to say, well, 5 times 3 to the 14th power. And this is a very large number. I will give you the heads up. So when you plug that into your calculator, you get 23,914,845. Okay. And yes, it should be very large numbers because this is exponential functions. Okay. So remember, exponential functions get really big really fast. Okay. They start out small, or they could potentially start out big and go smaller, but nonetheless, it's going to happen fast. Okay. So that's why, yes, you are going to have big numbers. Okay. All right. Sorry, I was looking to see where we're at. Okay, so here on number 3, again, we're going to say, okay, 2 to 3, you add 1. So I need my initial. So I need to find out, well, what is it at 0? Okay, so I'm going there. Well, I notice if I do 500 divided by 250, okay, or not divided by, yeah, divided by, okay, I get 2. But I need that to be something I can multiply. Okay, so I don't take 500 divided by, times 2 to give me 250. I'm actually going to, let me move this. That's in my way. I'm actually going to take 500 and divide it by 2, which is the same as multiplying by 1/2. Okay, 250 times 1/2 gives you 125. That looks like a plus sign. Okay. Going backwards to find my initial, instead of multiplying by 1/2, this time I'm going to multiply by 2. 500 times 2 is 1,000. 1,000 times 2 is 2,000. Okay. So I know my initial value is going to be 2,000. Okay. My common ratio is going to be this number here, the 1/2. Okay. Now, because the common ratio is less than 1, that's going to be a decay. So to write my function, the equation, I'm going to get, well, 2,000 times 1/2 to the x power. And to find what f of 12 is, I would say, okay, well, 2,000 times 1/2 to the 12th power. And it is going to give you an extremely small decimal. So it's going to give you 0.4882, ... You can also say it is 125 over 256. Okay. That is also what it is equal to. And that fraction is going to be more accurate than the abbreviating a decimal or approximating a decimal. Okay. All right, so let's go. Now they don't give us a table. Now they just give us 2 points. So this 2 here, f of 2, that's going to be an x value. And 4 is a y value. Okay, 3 is an x value, and 8 is a y value. Okay, so I'm going to make my, why did I put 3? X. So I'm going to go ahead and make my table. I know I need to start at 0, so I'm going to go 0, 1, 2, 3. Okay, and as a reminder, you need to start at 0 to find your initial. So I know that 2, when x was 2, y was 4. When x was 3, y was 8. Well, I know to go from 4 to 8, I can times 2. Okay, so to go back up here, I'm going to say, okay, 4 to something, I'm going to divide by 2 and get 2. And then 2 divided by 2 gives me 1. So I know that my initial is 1. And my common ratio is 2. Okay, so to write this function, I would say, okay, not y. We use f of x, sorry. We would say, well, okay, well, f of x is equal to 1 times 2 to the x power. Now, this is the only time that you can really write it like this. So think about this. I'm going to pose a question to you. If I have 2 to whatever power, and I do that, I do the 2 to the, say, 12th power. If I multiply it by 1, does it change anything? No. So because it doesn't change anything, I can just say that f of x is equal to 2 to the x power. And the reason being that I can do that here is because 1 times anything is itself, so it doesn't change anything, okay? So one thing to note, and she does make this note, is that you can check your calculator and table to make sure that you got it correct. Okay? Because this equation should give you these values. Okay? All right. So moving right along. Okay, so -1 is an x value. 8 is a y. 2 is an x. 1 is a y. So we're going to do our table. So -1 and 8. And then I have, 2 and 1. So I know I'm going to have 0 and 1. Okay. Now, on this one, you kind of have to just think for a second. So if I was going from 8 to 1, I would need to get smaller, okay? So this is kind of going to be a trial and error, okay? Sorry, I was thinking for a minute. If there's another way to explain it. But I know if I take 8 and I times it by 1/2, that gives me 4. Well, 4 times 1/2 gives me 2. And 2 times 1/2 gives me 1, okay? So the common ratio is going to be 1/2. And so my initial would be 4, okay? So that means that f of x is going to equal 4 times 1/2 to the x power. And again, the same thing that I said over here. You can also check your table, your calculator and table there. Okay? All right, go ahead and pause this if you need a minute. I know I'm kind of working fast. Okay. All right, so sorry, I got sidetracked. Okay, so let's go ahead and do this one here, okay? All right, so now this is just your instructions, by the way, okay? But here's your instructions, and so it's wanting you to write the equation that goes with this. So it already tells you that your initial value is 2048, so that's going to be your A. Half is going to be your B. Now, it is decreasing, so that is how we know that it has to be the half, because it can't be greater than 1. So my function would be f of x equals 2048 times 1/2 to the x power. Okay. Now that's all it's asking for there. You don't have to do anything beyond that. Okay. So on this next one, 5, that's your A. 1.25 is your B. So you would have 5 times 1.25 and then x. And that equals f of x. Okay. All right. So on the next one, it's graphs again, so it is a little boring, I won't lie to you. Okay, but one thing to know is that since exponential functions are all 1-to-1, that means they are also invertible. And invertible just means that they have an inverse. Okay, all that means. Okay, so we're going to put both of these graphs on the same plane here. One thing, and I'm actually go ahead and show y'all this right now. I said I was going to show y'all on Friday in class, but I'm going to go ahead and do it just real quick since I have y'all's attention. One thing to know that when you have log, whoa, I covered up what I needed. There we go. When I have a log that has a base, the base being the 2, that is not 10, you have to change the base in the calculator. Unfortunately, the calculators that are there in my classroom are actually in test mode, so you can't actually change it to a 2. So what we will do, here, I'll just go to Chrome. We're going to use Desmos, and I want to make sure that y'all know how to type that in, because I am going to let y'all use it on your test. You can just use a Desmos since you don't have that opportunity. And so remember, it was log base 2 of x. So I would need to click my functions button. And I'm going to go all the way down to where it says log of a right here. Okay. And so where it's blinking, I'm going to put a 2. And then I would come over and do an x. Okay. All right. Now, if you're looking at your notes, you see that we actually have to formulate a table or create a table. So using Desmos, the way to get a table is to click the settings button and then click that table right there. Okay. And that's going to be how it creates that table for you. Okay. Let me see if it'll let me split view this. No, I don't want to do that. Oh, crud. Oh, well, y'all should already have all that, I guess. Oh, we're good. Oh, I don't want the key. I want this. Sorry, guys. Okay, so your table here on the 2 at log base 2, we're going to do, so -2, well, sorry. That's undefined. And this is just off the table. Undefined, and then 1 is 0 and 2 is 1. Okay. Full screen. Okay. So now you can do the 2 to the x power. You can do that easy in your calculator. So 2 to the x power at -2, our y value, where did my pen go, is 0.25. And then we get 0.5, 1, 2, and 4. So as a reminder, because these are invertible, all that means is that I can change and flip, if you will, my x and my y values, okay? So we do need to go ahead and graph this. So I'm going to graph it in 2 different colors just because I want to keep it clear. All right, so -2 was what, 0.25? -1 was 0.5, 0, 1, 1, 2, and 2, 4. You can even go further and say 3 is at 8. Sorry, that's not perfect. Okay. And then graphing my other function, let's do purple. We would just do the same. Okay, so instead of 1, 0, it's going to be, or 0, 1, it's going to be 1, 0. Instead of 1, 2, it's going to be 2, 1. And then you would have 3, not 3, 8. You would have 8, 3, sorry. And you get something like this, okay? So now notice you have a slant asymptote here, which it doesn't talk about this, but just to kind of to remind you, here's your slant asymptote. Well, thereabouts, okay? All right, so now again, moving along to the e of x. So e of x, -2 is going to be 0.135. -1 would be 0.368. 1, 2.718, 7.389, okay? Okay, and then this right here, LN, that means natural log. Okay, so -2 is undefined, -1 is undefined, 0 is undefined. 1 is 0, 2 is 0.693. Okay, and so we're going to graph these again. So at -2, all right, so there's that graph. And then let me change my color. And so then I have 1, 0. And so this one's going to be something. Whoa. Like this, okay? All right, now I'm going to finish this page really quick, and then I'm actually going to start a new one because uploading a video at my house is not very good. It doesn't go very fast. So I'm going to split this into 2 videos. But one thing to note is that, so log base e of x, that is notated by the natural log. So I'm reading this right here. Okay, that's the way you would write that. If you have something that says like this, log of x, there is not a base right here. If it does not have a base noted, that base is 10. If you have something like this, log with a subscript of 2 and then an x, that means that that log has a base of 2. But if nothing is there, the base is 10. Okay, and that's also known as the common base, which is the reason for just nothing being there. It's just a common base. Okay, all right, so I'm going to go ahead and stop this video so that way the videos aren't too long to upload, and then I will start a new video going over pages 7, 8, 9. Okay.